Hello everyone, this is Adnan and this is our next lesson in the series where we are covering the entire IGCSE Cambridge Chemistry syllabus. The course code is 0620. In this lesson, we will be covering topic 2.2, atomic structure and the periodic table. So this topic 2.2, it has different subtopics, mainly six. The first one is describe the structure of the atom as a central nucleus containing neutrons and protons surrounded by electrons in shells. So how basically an atom looks like. So we have a nucleus in the center which contains neutrons and protons. I'm denoting neutron with lowercase n and proton with lowercase p. And then there are shells in which electrons are arranged. So we can have a first shell, we can have a second shell, and we can also have a third and fourth shell and so on. So this is how basically the an atom looks from the inside. So yeah, so this is the basic structure of an atom. These and protons, neutrons, and electrons. These are the three fundamental particles that are found in an atom. Protons and neutrons, they are found in the nucleus at the center, and electrons, they revolve around this tiny nucleus in shells. So that is a shell. Okay, so this was all about subtopic 1. Describe the structure of the atom as a central nucleus containing neutrons and protons surrounded by electrons in shells. Now we move on to the second topic, which is state the relative charges and relative masses of proton, neutron, and an electron. So in our previous topic, we introduced the three fundamental particles that are found in an atom: protons, neutrons, and electrons. Now we will talk more about them. So let me just draw a table. So subatomic particle, their mass, or let me write charge here, and let me write relative mass. Okay, so let's start with a proton. So proton will have a positive charge, and it will have a relative mass of 1. And then we have a neutron. It doesn't contain any charge, so we are writing 0, and its relative mass is also 1. And then I'm going to write electron. Electron contains a negative charge. It carries a negative charge, and its relative mass is approximately 1 over 2000, which means that it is 2000 times lighter than a proton and a neutron. So it is very light with a negligible mass. So this is more about protons, neutrons, and electrons. Now we move on to the next topic, which is define proton number, or which is also called the atomic number, as the number of protons in the nucleus of an atom. So the definition is also given in this statement. So basically, in an atom, the total number of protons, they are called the atomic number of that atom. For example, in hydrogen, where we have only one proton in the nucleus and one electron in the outer shell. So the atomic number for hydrogen atom will be 1, and it is written on the bottom left side of the atom. This is the standard notation. This is how we represent atom with a symbol. All right, so for lithium, which contains 3 protons in its nucleus and 3 neutrons, that's the nucleus of lithium atom with 3 protons and 3 neutrons. So the atomic number for lithium will be 3, just because it contains 3 protons. So for atomic number, you just have to count the number of protons in an atom. So I have a question for you. what will be the atomic number or proton number for the element zinc. So you can use a periodic table to figure this out and answer this question in the comments below. Okay, so we move on to the next topic, which is topic number 4. It says define mass number, or which is also called the nucleon number, as the total number of protons and neutrons in the nucleus of an atom. So as again the statement is self-explanatory, it is introducing a term which is a mass number. So what is a mass? What is mass number? Mass number is basically the sum of protons and neutrons in the nucleus, right? So this is called a mass number. So for example, for lithium now, what will be the mass number? It has 3 protons and 3 neutrons. So yes, that's right. Mass number will be 6. So again, for helium atom, for example, where we have 2 protons in the nucleus and 2 neutrons, and then in the first shell we have 2 electrons. So the mass number for helium will be 4, because 2 plus 2, 2 protons plus 2 neutrons, we get 4. So this is basically what a mass number is. So whatever is in the nucleus, you just have to add it up to get the mass number. Okay, now we move on to the fifth subtopic of topic 2.2, atomic structure and the periodic table. Determine the electronic configuration of elements and their ions with proton number 1 to 20, for example 283. Okay, so as the number of protons and electrons they increase, so shells also increase. What are shells? The the path on which electrons revolve around the nucleus. So we can have many shells in an atom depending on how many electrons it has. So in the first shell, let's say this is a nucleus. So in the first shell, we can accommodate the maximum number of electrons that can be accommodated in the first shell are 2. In the second shell, we can have 8 electrons at maximum. So 1, 2, 3, 4, 5, 6, 7, 8. And in the third shell, we can also have 8 electrons. We cannot have more than 8 electrons in the third shell, just like in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. And in the fourth shell, again, we can have electrons. So, but in our syllabus, we have to learn this up to element number 20, which is calcium. So calcium has 20 protons, which means that it will also have 20 electrons, because atoms are neutral and they usually have they have the same number of protons uh, and electrons. Okay, so now let's fill these 20 electrons in the shells. Let me just write it here. Shell number 1, 2, max number of electrons, maximum number of electrons, 2 for first shell. For second shell, we can have 8. For the third shell, we can have 8, and the remaining, they will go to the fourth shell. So now okay, so in the first shell, we write 2 electrons, and then we write a comma. This comma represents that now we are going into the second shell. So for second shell, out of 20, we have used 2 electrons. We have 18 remaining, but out of 18 remaining, only 8 can enter the second shell, because we have a limit, as I've explained it here. We cannot have more than 8 electrons in the second shell. So now that we have added 10 electrons out of 20, Now 10 are remaining. So now we move on to the third shell, and again we have a limit. We cannot exceed 8. So the third shell will contain 8 electrons, and then a comma, which represents now that we have to go to the fourth shell. And now this will be the remaining 2 will be in the fourth shell. So this is how we write the electronic configuration of elements. Now, what are ions? Ions are charged particles where atoms have lost or gained electrons. For example, aluminum, if there is a charge of 3 plus, so that's an ion, right? It means that it has lost 3 electrons. So what I'm about to tell you, it is very important that when you see a positive sign on an atom, it means that it has lost electrons, and the number of electrons lost will be equal to the charge on an atom on this ion. So it is 3, which means that aluminum has lost 3 electrons here. So this is very important, and you should write it down, or you should practice. You can make a flashcard about ions, right? About this concept. And let's say we have a nitrogen atom and we see a charge of 3 negative. Now, if you see a negative charge on an atom, it means that it has gained electrons. And how many? It will also be equal to the charge on that ion. So we see 3 here, it means that nitrogen has gained 3 more electrons. Okay, so normally for aluminum, how many electrons are there in aluminum? If you look at the periodic table, you will find the atomic number, which is 13. So there are, in a neutral aluminum atom, we have 13 electrons. But since there's a charge of 3 plus, which means that it has lost 3, so now we have 10 electrons in this aluminum atom. And for this nitrogen atom, in nitrogen we have 7 electrons, and because its atomic number is 7, which is the number of protons, and for a neutral atom, the number of protons and electrons, it is the same. So, but now we have a 3 negative charge, it means that it has gained 3 more. So on top of 7, we have to add 3. So 7 plus 3, we also get 10. So nitrogen here, this nitrogen ion, it also has 10 electrons. So when ions appear in the questions, so you have to be careful, because you will have to figure out that how many electrons are there in that ion, and then you will write the electronic configuration accordingly. So I've added a question from the past paper at the end of this lesson, so where I will explain this, and then it will become more clear. So now we move on to the last topic of this subtopic, which is 2.2. So 2.2.6, it states that uh, you know a group 8 noble gases have a full outer electron shell. Okay, so in order to explain this, I will have to paste a periodic table here. So just give me a second. If you like my lectures, you can subscribe, like, and share it with your class fellows. And I also offer one-on-one tutoring sessions if you are preparing for GCSE, IGCSE, EdXL, any chemistry syllabus. You can contact me. My contact details are given in the description. So I'm pasting the periodic table here. Okay, so this is the periodic table. Okay, so we will be using it for a reference. Okay, so now let me read this again. It states that a group 8 noble gases have a full outer shell, full outer electron shell. The next one, it says that the number of outer shell electrons is equal to the group number in groups 1 to 7, and the number of occupied electron shells is equal to the period number. Okay, so in order to explain this, let me change this pattern a bit. I'll start from B and C. So you can see that there are 8 groups on the periodic table. uh, this is group 1. You see the Roman numbers here. So this is group 1: lithium, sodium, potassium, rubidium, cesium, francium. The vertical columns on the periodic table, these are called groups. So groups are vertical columns, and there are 8 groups in the periodic table, right? So we have 8 groups. Let me just write the Roman numbers. Okay, V111. Okay, and what are periods? Periods are the horizontal rows. So periods are horizontal rows from left to right. This is period number 1 that contains hydrogen and helium. This is period 1, and that's period 2, starting from lithium and then beryllium, boron, carbon, nitrogen, and neon. And then this is period number 3, which contains sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So we have 7 periods in the periodic table and 8 groups. You should remember this. This is very important. So V11, or like 7, right? 7 periods. So the group number, it tells us the number of outer shell electrons. For example, lithium, since it is in group 1, it means that we will have only 1 electron in the outer shell of lithium. If we draw its electron structure, you see that its atomic number is 3. So the number of electrons will also be 3. So 2 electrons will there be in the first shell, and the third one will go to the second, because first one can only accommodate 2. So you can see that it is in group 1, and this is the outer shell. Second shell is the outer shell for lithium, and we have only 1 electron here. For sodium, that has 11 electrons. So 2 in the first, 8 in the second, and then the 11th electron will be in the third shell. So yeah, so 1 electron in the outer shell, right? Similarly, carbon has 6 electrons in total. It is found in group 4, you can see here. So carbon, the atomic number is 6, which means that it will have 6 electrons, because atomic number, proton number is 6. So number of electrons will also be 6, because it's neutral atom. We don't see any charge here. So 2, and then what will be so 4. So second shell, 4 electrons, group number 4. So group number will always be equal to the number of outer shell electrons. So let me just write it here. Group number equals to number of valence electrons. Okay, so now let's take a look at period. So period means the number of shells. So let's say if we have an element which is from a period 1, 2, 3, 4. So calcium, for example, calcium is in period 4. This is period 4, starting from potassium. This is period 4 from left to right. Right. So now all these elements, they will have 4 shells. The calcium, it will have 4 shells, like 1, 2, 3, 4, right? And so a krypton, it will also have 4 shells. So this is basically what this topic is telling us, that the number of occupied electron shells is equal to the period number. So for example, if I ask you that how many shells are there in zinc, so you just look at the period number from the periodic table, and that will be the answer. Since zinc is in period 4, so which it means that there will be 4 shells in zinc. Okay, so this is how basically we figure the number of shells. And now let's talk about noble gases. So group 8, it is called the noble gases. So all of these elements in the noble gases group, or group 0 or group 8, these are the different names of for the same group, group 8. We have all these atoms, they will have a complete outer shell. For example, helium, which contains only one shell, so it will have 2 electrons because that's the maximum that the first shell can hold. And neon, for example, it is in period 2, group 8. So first shell, it will have 2 electrons, and the second shell, it will be complete with 8 electrons. The atomic number is 10. 1 2 3 4 5 6 7 8. So for argon and krypton, you can draw the electronic structure by yourself, and you will see that their outermost shells are also complete. So we will talk more about this in our upcoming lessons in chemical bonding, that why this concept is very important and why we are emphasizing that group 8, all the atoms, they have a complete outer shell. So this was today's lesson. Oh yeah, so we have this one question to practice. Okay, so question 11, this is from past paper, paper 4, extended iron ore contains iron 3 oxide, Fe2O3. A blast furnace is used to extract iron from iron oxide. Equations for some of the reactions in the blast furnace are shown, blah, blah, blah. 1F, both iron 3 oxide and aluminum oxide contain metal ions with a 3+ charge. Write the electronic configuration of aluminum ion. And okay, so now this is what I was talking about previously, that you have to be careful when they give you an ion. So if you look at the periodic table, and aluminum, it is here, and we have this is the atomic number 13. So it will have 13 electrons, right, in its neutral state. But here, since it has a 3+ charge, so it means that it has lost 3 electrons. So the total number of electrons remaining in aluminum will be 13 minus 3, so it's 10. So now we have to write the electronic configuration of 10 electrons, right? So out of 10 electrons, 2 can be accommodated in the first shell, and we cannot have more than 2 in the first. Now we go to the second shell, and the remaining 8 electrons will be filled in the second shell, so 8 electrons. So this is the answer, but most students, they make a mistake. They may write the electronic configuration as 2, 8, and then 3, which will be incorrect. And some of them, instead of subtracting, they may add 3 electrons in 13. So 13, that's going to be 16, and then they will write 2, 8, and 6, which will also be incorrect, right? So the total number of electrons in aluminum 3+ are 10. Remember this. Okay, so here deduce the number of protons and electrons in an iron ion. So here again we can see that iron has a 3+ charge. If you look at the periodic table, so this is iron here, and the atomic number is 26. And now that we have a 3+ charge, it means that it has lost 3 electrons. So 26 minus 3, we get 23. So this will be the number of electrons. And number of protons, no matter what the charge, whether positive or negative, and the number of protons, they don't change ever. They remain the same, because it is the number of protons that give the identity to an atom. For example, hydrogen, it has 1 proton. If you change this number of proton, if I add another proton in hydrogen, it will not remain hydrogen, and it will be converted into helium with 2 protons. So when the number of protons change, the atom changes. So again, I repeat that no matter what the charge is, the number of protons, they will always remain the same, which is the same as the atomic number on the periodic table. So this was our lesson 2.2. This will be all from my side today. You can join my school community, High School Chemistry, on school.com, where I provide group lessons. Once a month, it's for free, and you can subscribe to a premium package where I offer 4 lessons in a month, once one lesson per week, where we cover the entire IGCSE Chemistry 0620 syllabus. And other courses are also offered if you are affiliated with Edexcel, IGCSE Edexcel, or AQA. So we cover these exam boards as well. So, and if you need one-on-one lessons, so the Google form is given in the description. You can fill that, and I will contact you. So this will be all from my side, and I'll see you in the next one. Take care. Goodbye.